lecture basically related to our these operators, data types, whatever the thing we have already discussed earlier in our last few lectures. Okay, so still if you are facing any difficulty after that these lectures, just go through it, revise all those concepts, and if you are facing any difficulty, just let me know. Okay. So in today's lectures, so in the last few lectures, we have discussed about your data types, their ranges, how we should go for the name of your variable, and then we have gone through the operators, that what are the increment operator, decrement operators, what are pre, post. Based on those operators, we have solved few questions too in our last lab. Now we have also gone through bitwise operators too, out of which we have discussed these three operators right now. Okay, and these two also we have discussed, but with respect to negative numbers we haven't discussed. So in today's lecture, our entirely focus is on towards your negative numbers. Okay, how we are representing negative numbers, even though I have shared the slides with you or the YouTube link related to that, but still in this lecture I'm going to discuss about the negative number, how to represent negative number in your Java programming language. Okay, so we have already discussed conditional operators too, and also one more thing which you need to remember is the precedence of operators. Okay, so suppose if you are having the priorities, okay, so priority wise we always give plus plus. Okay, so suppose if we are having some expressions, so always give the highest priority to this expression, the expression which is consist of your plus plus, either post increment, pre or pre increment type. Okay. Similarly, after that, you will give the priority to this multiplication, division, and mod. Then after you will give the priority to plus minus. Then you will give the priority to these shift operators, then relational operators. So you should keep in your mind that if you are getting a very complex kind of expressions, okay, so in that scenario, from where we are going to start executing the code, because you know that if we are going to start any from any point or randomly, if we are going to start, so we will get some different result. So that is why they have already provided us the precedence of the operators, like which operator will be executed first by our Java compiler, and these are the hierarchy. So the last precedence is your assignment operator. It means first of all we are going to compute or whatever the expressions we have, then later on we are going to perform the assignment operator. And just before ahead, we will give the highest priority to the conditional operators. And then you can see over there that first of all we give the highest priority to bitwise AND operator, then bitwise XOR operator, bitwise OR operator, and then before your logical operators. Okay. So if you have an expression where you have bitwise AND operator as well as logical AND operator, both the operators suppose you are using it. So first of all, it will give the highest priority to bitwise AND operator in comparison to bitwise, logical AND operator. Okay. So always keep in your mind. So I've already shared these slides. Even I have uploaded these slides on your LMS also too. So I have created a single cohort of your group one and group two, where I have uploaded the first two basically these slides. Okay. Now, in today's lecture, we are going to discuss about the negative numbers. Okay, so let's go through it, how we are going to represent a negative number. So first of all, I just want to show you, first of all, I'm going to compile one code, this online Java compiler, where I will show you that what output we are getting it if we are going to execute a code. Okay. So you can see over there, my number is your positive of your 10. Okay. So there is a operator, and that operator is basically known as your uh, this operator, sorry, your bitwise complement operator. So first of all, we will study about the bitwise complement operator. So as I told you that bitwise complement operator is also known as binary ones complement operator. Okay. So over there we are just performing flipping of bits. Okay. So if you have 1, so it will become 0. If you have 0, then it will become 1. So for a positive number, let's go for means let's take one example. Okay. So if we have suppose int this x is equals to 4, okay, and what we are doing it in our system.out.println, we are printing the value, and over there we are just performing this operation, and we are just performing the complement operation. On this, let's take 5 instead of 4. Let's take 5 because 5 required because 2 of bits will be there in your 5. Okay. So if we are going to execute this code, so what output we are getting it? We are getting the output -6. Okay. So you can see over there, if we are performing the complement operator of this your x is equals to 5, so what answer we are getting it? We are getting the answer -6. So how we are getting the -6 over there using this complement operator, we will check it out. Okay. So let's take, first of all, what we will do, as I told you that whenever we are performing bitwise operators, okay, so it will, we are basically we our entirely focus upon that how we are basically storing these values, okay, whatever the decimal values into our in our machine language. So for our positive numbers, you know that as this will be your 32 bits. So I'm not representing all the numbers. I'm just showing you some few numbers. Okay. So this will be my MSB bit. So in the case of your integer bit, so you already have an idea that there are 31 bits are representing the data part, okay, or you can call it as your value part, while rest 1 bit are basically related to your sign bit, okay. So in our question we have x is equals to 5, so it means it is a positive number, so that is why we are getting 0 over there. Then after that we will have all zeros. If you are going to convert it into your, if your number is what, x is equals to 5, okay, so how you are going to represent your x is equals to 5? You are going to represent x is equals to 5 is like that, okay, 1 0 1. So this is what, 4 2 1, like that. So that is why you will get 4 1 0 1 is the representation of what your this your x is equals to 5. So this is basically the representation of x is equals to 5. Now what we are performing, what operation we are performing, the operation which we are performing over there is complement operation. Okay, complement operation on this x. So as according to our definition, what we are doing it, whenever we are performing this complement operation, we are flipping the bits. Means 1 will become 0 and 0 will become 1. So what will happen? Here we will get what? 0 over there. Got it? Here we will get 1 over there. Here we will get 0 over there. And rest all other bits. You can see over there all are what, 0. Okay. So all the bits will become what, 1 1 1 1. So you already know that these are what? These are total 31 bits. So I'm not representing the entire bits right now. So all the bits will become what? 1. And also over here, 0 will also become 1. So my sign bit will also become what? Initially it was 0. Now because we are performing complement operation, so it will become 1. Now this, as you can see it over there, that now here my MSB is what? MSB is my negative number. How can I say that my the after performing this complement operation I am getting a negative number? Because now my MSB bit will become 1. Because earlier it was 0, now it was 1, and 1 always represent a negative number, okay, in the MSB. So that is why this result we are getting. But if you are going to convert this number, okay, So you all now you have an idea about the entire number system. If you are going to convert this number, then you won't be able to get -6. So for -6, this is not a representation. Okay. So what I just want to tell you is that this is basically how we are basically storing a number in your machine level. Okay. So in the machine level, we are going to store this number. So as I told you earlier also, for negative number, your machine level is not equal to, okay, your machine level code is not equal to your logical code. So how to find out what number it is representing? Okay. So in order to do that, what we are going to do, we have to perform 2's complement operation. Okay. We have to perform 2's complement. So you know that whenever we are performing, always remember, this is also a very important point, is that you always perform 2's complement operation only on the value part, not on the this your sign bit. Okay. So what I will do, I will put 1 over there. So whenever we are performing 2's complement, because 1, this bit is always is basically representing negative number. So that is why we are not going to touch this bit. Okay. So it will remain 1, while in the rest of the bit, what we are going to do, we are going to perform your what we call it as your 2's complement. So 2's complement are going to be performed. First of all, we are going to perform 1's complement, then we are going to add 1 over there. So these are the steps which we are following whenever we are performing 2's complement. So the result which we are getting it over there is 0, 0, 0, 0, 0, 0. All the ones will become 0 because we are performing 1's complement. Then here 0 will become 1. Here 1 will become 0. And here 0 will become what, your 1. Okay, like this. Now after that, what I told you that you have to perform plus of 1. So if you are going to perform plus of 1, then the output which we are going to get it over there is 0, 0, 0. All zeros we are getting it. Then 1, 1, we will get 0. So we will have a carry forward of 1. So that is why 1, 1, 0, we will get it. Now if I'm going to ask you about that, what is the if we are going to convert this binary number into decimal number, what is the value? So you will get the value is like this is 4, this is 2, this is 1, this is 8, like that. So you know that this value is what is 6. Now whether it is a positive number or a negative number, it is a negative number. So this number which I'm right now, which we have performed using 2's complement, which I have which we have computed, is basically a logical level code. Okay. So what I want to show you is that in your Java programming language, -6, okay, -6 is represented like that. -6 is represented like that. But if we are going to compute it, we won't be able to find out. Okay. So that is why what we are going to do, we are performing 2's complement. Okay. So this is what you need to which means you should know about that part. Okay. So whenever you are getting any negative number, okay, so first of all, if it is in machine level code, no need to perform any 2's complement. So then you need to convert it into your logical code. So this similar thing I have also shown you like earlier PPT also, like here in this PPT, is that suppose if we have your this is for our positive numbers. Okay. So for positive numbers, you don't need to worry about that part. Okay. So for positive numbers, this value will become what, your 0. Okay. And this is how you can represent a equals to 30 over there. So for positive numbers, your logical code, always remember, your logical code and your machine code, I'm just writing like that, machine code, both are equal to each other. Okay. But
सर अब स्टक हो गया सर।
सर आप हैंग हो गए।
यस सर।
सर आपकी स्क्रीन हैंग हो गई।
भाई पहले भी हो रहा था क्या ऐसा, मतलब मेरे साथ तो हो रहा था
सर आप
बीच
पे
बीच
भी
में।
ड्राइवर हो गए।
मेरे साथ भी 2 मिनट तो है।
नहीं गाइज ये पहले भी हुआ था क्या, क्योंकि मेरे साथ भी 2-3 बार हुआ है ये।
हाँ तो 2 मिनट
मतलब
शांति तो रख भाई, देख तो लेंगे सर आ रहे नहीं आ रहे।
आ रहे हैं ना, चैट बॉक्स देखा कर जरा।
5 minutes।
Till then, what I'm telling you is related to. Am I audible now?
यस सर।
Okay, okay. So
यस।
till just telling you about concept is that whenever you are going to use your negative number, always try to go for your like negative numbers. Always try to convert it into two's complement. Similarly, like after some time, once I'm going to open my system, I will even show you like if we are going to add one number. Okay, like
Sir,
yes.
are you presenting?
No, no, right now I'm not presenting because I'm not, I'm on my phone. So just wait
Okay, okay.
because, yeah, I'm just restarting my system. I'm having some issue. Okay. So, right now I'm just telling you about the concept is that similar concept of, related to our two's complement are going to be applied whenever we are basically incrementing the value in your byte number. Okay. So you already know that whenever we have byte b is equals to 127, and if we are going to increment its value by 1. Okay. So generally what happen in that scenario? In that scenario, you always get minus of 128. So how you are getting minus of 128? Because in your in your Java programming language, you want means you are not basically uh, representing minus 0. So you already know that you have only one value for 0, that is your positive 0. You are not representing minus 0 in your what in your Java programming language. So how you are going to represent minus 0 in your Java programming language? If you are going to again convert it into your logical code, so you will get minus 128. So you can directly say that if you are going to convert your minus 0 in your logical code, okay, of your this your in your Java programming language, then minus 0 is represented as minus 128. Always remember, minus 0 is represented as your minus 128. So I will show you, just wait for it. Why this? It is taking a lot of time to open. Okay, yeah, now it's open. Okay, just I'm just leaving from the here and I'm joining from my system. Okay, just wait.
20 मिनट में ही खत्म हो गई तो।
Okay, so now am I audible?
Yes, sir.
Yes, sir.
Yes,
Everything is
sir.
fine.
Yeah. Sorry for that. Okay. So my screen is visible now.
Yes, sir.
Yes,
Okay.
sir.
Yes, sir. Yes, sir.
So,
Yes, sir, visible.
yeah. So till now, what we have discussed is that whenever we are going to store a negative number, so negative numbers are going to be stored in the form of your 2's complement. And whenever you are going to perform bitwise operators, so what you do, all these bitwise operators are going to be performed on your bits. Okay, so suppose if you have 4 and 5, so it's not like that you are going to perform 4 and 5, the AND operator on 4 and 5. First of all, you are going to convert this 4 into your machine level code, and then you are going to convert this 5 into your machine level code, and then you are going to perform this OR operator, AND operator, or bitwise complement operator. So for positive number, it is quite easy to perform all these operations. But for negative numbers, it's quite complex in comparison to positive numbers. Why? Because in Java programming language, numbers are basically stored in your in your 2's complement number. Okay. So whenever you are getting any question related to that, okay, so your first step is first find out whether it is a positive number of or it is a negative number. Okay, so suppose if you are getting int x is equals to 5, okay, then no need to worry, you can perform whatever the operation you want to perform. But if you are getting x is equals to minus 5, and if that particular number is your what your negative, and you have to perform bitwise operation, so first of all what you do, you just find out the 2's complement. So what I will do, first of all, I will find out the 2's complement of this number. So for 2's complement, first of all, what I will do, I will first convert this number into your bitwise number. Okay, minus 5. So how minus 5 is represented in Java? It is basically represented, MSB will be 1, then you will get all the zeros, okay, and then in the last 3 bits over there, bit place, you will get 101. This is how basically you represent minus 5. Okay, so till now if somebody is going, so a human can understand minus 5 like this. Okay, so if I'm going to ask you about that, what is this number, so you can directly tell me, okay, this is minus 5. But if we are going to say, if we are going to give this number to our Java compiler, so Java compiler will never say that, okay, this is minus 5. Why? Because according to Java, this is not minus 5. This is something else. So in order for a Java compiler, minus 5 is basically 2's complement of this number. Okay, 2's. So what the number which we are basically understanding it, we have to perform 2's complement on that particular number. So what we are going to do, we have to perform, and always remember, we are performing 2's complement on only on data part, not on this part. Okay, so no need to change this bit. Otherwise, I have seen like sometimes a student perform, whenever they are performing 1's complement, then they also flip the bit of MSB2. No need to flip the bit. Okay, so whenever you are performing 2's complement, so what will happen here, you will get one again, you will get it, then you will get all ones over there, and then you will get what? 1 0 1 0. Then you have to perform +1 over there. Okay, this is how you basically perform the your two's complement operation. So this is basically the representation of -5 in your Java compiler. Okay, so according to our logical knowledge, -5 is represented like that. But in machine, how our -5 is storing in Java programming language? Like this. Okay, in two's complement form. Now, after that, whatever the operations we want that you should perform, you can directly perform those operations. Okay. Later on, whatever the operation, if I am going to ask you about, you have to perform complement operation, or operation, and operation like that. Now you are going to perform all those operations like that. So these are the steps which you need to follow if you are getting a negative number. Like here in this case, x is equals to -5, and I want to perform an operation on x is equal, on this your x data variable. Okay. So first of all, find out the two's complement, then perform the bitwise operator, and along bitwise operator, if you are getting a positive number, then it is okay. Okay, so I will show you when we are going to get the positive number. Otherwise, if you are getting a negative number, then you have to again perform two's complement. Okay, so what I'm telling you is that suppose you have to perform. Okay, so you have a number x is equals to -5. Okay, right, because we have already discussed right now. So int x is equals to -5, and I want to perform the complement operation, complement or not operator on this x. Okay, so if you are going to perform this operation, what output you will get, we have to find out. Okay, let's stay. So we are just printing this value. Let's assume system.out or println this value. So if we are going to print the value complement of -x, so what output we will get? So what are the steps which you need to follow? Let's go through one by one. First of all, we will check whether it is a positive number or a negative number. Yes, it is a positive number. So what I will do, I will first write it down, which I have told you, and I will just convert it into the binary number. So logical binary number. So logical binary number of -5 is this. I'm not writing, oh, there are all zeros. Okay, so because the numbers are means the number of data value will be 31, so that is why I'm not representing all the zeros. I'm just representing the major values, like these are the values, and this is my MSB bit. Okay, while rest of all bits will be our all zeros. Okay, like that. Now after that, what we are doing, we have to, because this is a negative number, so we in Java the numbers are basically stored in two's complement. So I will perform the your two's complement. First of all, I will perform one's complement. So once I will perform one's complement, so all zeros will become 1 and all ones will become 0. So here I will get 0 1 0. This is what I will get. Okay, then after that, what will happen? Once I will get this thing, then I will perform addition of one number. I will do it over there, and then I will add 1 over there. So this is the two's complement representation of what my -5. So this is how -5 is represented. Okay, so -5 represented in Java programming language is like that. Now after that, as I told you that we have to perform bitwise operation. That is what your not operator. Okay, so we have to perform not operator over there. So whenever you are performing not operator, one thing which you keep into your mind is that in your not operator, you are also flipping the MSB bit too. Okay, for not operator, whenever you are performing this bitwise not operator, in that scenario your MSB bit will also participate in that particular operation. Okay, so you know that if you are going to perform the your bitwise not operator, so we are going to flip all the bits. Okay, so here your 1 will become 0, all the ones will become what, your 0 0 0. Here it will become 1, or rest of the bits will become 0. Now from this you can directly conclusively you can say that this is what a positive number. Why it is a positive number? Because here your MSB bit is what your 0, and your for positive numbers your logical number as well as your machine level number. Okay, the way our Java is basically storing these values in the machine level, both are same. So it means that this number is what, 4. So it means if you are going to perform the -5, if you are going to perform the bitwise NOT operator of -5, so the output which we are going to get it over there is positive of 4. Okay, this is the thing. So now you don't need to convert it. Why we are not converting again in 2's complement? Why? Because here we are getting a positive number, and for positive number your logical code as well as machine code both are same. So that is why no need to again perform that particular operation. Okay. So here this is the case. See, -30 is represented in binary code like this. Okay. This is the representation of -30. So here 1 is representing that this is a negative number. Rest of the bits are basically representing your value part. So logically, if I'm going to ask you like just convert -30, so this is the answer you will get it. Okay. But in our Java compiler, -30 is basically stored in the form of 2's complement. So for that, what we will do, first of all, we will perform 1's complement. So in the case of 1's complement, always if we are going to perform in our data value part, so all the zeros will become 1 and all the ones will become what, your 0. Okay. See, all the ones will become what, your 0. And then after that, we are going to add +1 over here. So that is why we are getting this number. So now this is the representation of -30 in your Java compiler. Okay. So in your Java compiler, we are basically going to represent -30 like that. Okay. Now after that, what we are doing, we are performing complement operator. Okay. On this number. So what we are going to do, we are going to convert, we are going to flipping up all the bits. So that is why 1 will become 0, all and 0 will become 1. So I will get 29 over here. And that number is positive of 29. Why I am getting positive of 29? Because now my MSB bit of 1 will become what, 0. So for complement operator, your all the bits will participate. Okay, always remember for complement operator of this bitwise NOT operator, all the bits will participate. Okay, so that is why you are getting the output as positive 29. Now similarly, we have other operators too, which are your signed right shift operator. Okay, this is also a very important operator. So you already know the functionality of your right shift operator. So the left operand value is moved by the number of bits specified by your right operand. Okay, so this is just an example. So you can see over there, suppose if we have a number 0110, and if I want to perform right shift operator, okay, signed. So there are two types of right shift operator, signed and unsigned. So first of all, we are going to discuss about signed right shift operator. So here 1 is representing that how many times you want to shift. Okay, so we are saying that okay, we just want to shift by 1 place. So if we are going to perform right shift operator, then what will happen? This thing will be truncated. Okay, this value will be truncated, and I am going to shift all these values here. Okay, like this, 1 position towards right side. So this is the output you will get. So if you want to perform right shift operator, so this is the basic idea behind that. Okay, now for positive number, again, if you are performing signed right shift operator for positive number, no need to worry. I think in the lab also you have a question and you have just performed it, that particular question. So you are not going to, there will be no issue with positive number. But with your negative numbers, how you are going to perform? Okay, because again, logical machine both are different. So again, if you are going to solve, your first step is convert this number into your bitwise number. So after that, perform 2's complement. then perform right shift operator, and again perform 2's complement, and you will get your particular number. Okay, now let's go through one by one. First of all, what you do, this is how my minus 30 is logical binary code of minus 30. So logically, a human can understand, or a programmer can understand, that minus 30 is represented like that. Okay, but in Java programming language, minus 30 is represented like this. So you know that we have to perform 2's complement like that. Now, because we are performing this your shift operator towards right position, so you know that what we need to do, we are going to perform right shift operator over here. So here towards only one position. So what will happen? This one will come here. Okay, this 0 will come here. This 0 will come here. This 0 will come here. This 0 will come here, like that. Okay. So all these values will be shifted towards your right position. So this is the number you will get it. Okay. So this machine code you will get it over there, and whatever the number we are getting it, so this is the number output we are getting. But again, for a human, we cannot understand this code. Okay, you can you can interpret this situation like that. Okay, like we cannot understand this code. So how we are going to understand this code? Again, we have to perform 2's complement in this on this number. Okay, like we can understand this number, but can we understand that this number is what? We cannot say like that. Okay, because in Java, as I told you, everything is stored in 2's complement. So again, we have to convert our machine code into your logical code. Okay, that what output we are getting it. So whenever you are basically executing your code in your Java compiler, you don't need to worry about these concepts. Okay, you are getting the output. If you are going to perform, you will get whatever the output we are getting it. But how internally our Java is actually executing this code, this is what I'm telling you. Okay, so machine code we are getting it. Now we cannot say that this is the exact number we are getting it. So that is why we are again going to convert this number into logical code. So that is why, because this is a negative number. Okay, so for negative number, we know that our machine level code and logical code both are not same. So again, we want that what this number is, because I don't know what this number is representing. So that is why again I will perform 2's complement on this particular number, and after performing this 2's complement, what I will get this number. Okay, so it means it is representing minus 50. So after performing minus 30 on, if we are performing right shift operator for 1 bit place, if we are going to perform, so the output which we are going to get it over there is minus 15 over there. Okay, always remember, this is very important concept. Okay, so now it is, see, I have also written one statement over there, is now it is negative, hence logical binary code and machine code are different. Therefore again we have to perform 2's complement. And why we are performing 2's complement? Because we just want to understand what this number is, and logically we can understand, because you know that minus 30 is represented like this, but in Java it is represented like this. Similarly, this is a representation of a number in your Java, but we don't know what this number is. So for that, in order to make this number more understandable, what we do, we generally perform 2's complement, and the number which we are getting it over there is what? Minus 50. Okay, this is very important, and you should keep in your mind like that. Similarly, we have unsigned right shift operator also. Okay, so what is the, yes
सर अगर मतलब इस वाले पार्ट में अपन मतलब कोई ऑपरेशन लगा देते, जैसे नॉट ऑपरेशन लगा देते ऊपर -30 का, फिर मतलब नॉट लगा देते, तो सर इसमें एमएसबी भी चेंज हो जाती?
when you are saying, when we are going to apply this not operator,
सर 2's कॉम्प्लीमेंट के बाद मतलब अगर अपन नॉट लगाएंगे ना, तब पूछ रहा हूँ, मतलब पहले तो सर इसको 2's कॉम्प्लीमेंट में कन्वर्ट कर दिया, फिर इसमें नॉट लगा दिया, मतलब जैसे -30 है तो उसका नॉट पूछ रहे अपन, मतलब
जैसे हमारा ये प्रीवियस क्वेश्चन था वो बोल रहे थे।
हाँ सर वही। तो सर तो उसमें अगर सर मान लो इस 29 है, ये तो सर मशीन कोड का पता लग रहा है, तो सर इसको कन्वर्ट कैसे करेंगे लॉजिकल
नहीं
में?
नहीं, इसको कन्वर्ट नहीं करना है। सी वेन एवर यू आर गेटिंग पॉजिटिव, यहाँ पर तुम्हारा क्या मिला है, पॉजिटिव नंबर तुम्हें मिला हुआ है। गॉट इट? सो जब भी तुम्हें पॉजिटिव नंबर मिल रहा है ना, तो तुम्हारा जो मशीन कोड है और लॉजिकल बाइनरी कोड है, बोथ आर इक्वल।
अच्छा सर।
इस वाले केस में बोथ आर इक्वल, तो जब वो दोनों सेम है तो यू डोंट नीड टू कन्वर्ट इट। हमें कन्वर्ट कहां पर करना पड़ रहा है? ओनली इन द केस ऑफ निगेटिव नंबर, बिकॉज निगेटिव नंबर पे तुम्हारा लॉजिकल बाइनरी कोड एंड योर मशीन लेवल कोड बोथ आर डिफरेंट। ओके, लाइक दिस। तो लाइक हियर इन दिस केस, जैसे अभी हमने केस लिया था, इस केस में क्या था, जब हमने इसमें राइट शिफ्ट ऑपरेटर परफॉर्म किया, गॉट इट? तो यू ऑलरेडी नो स्टेप्स की हम क्या करेंगे, पहले -30 करेंगे, उसको कन्वर्ट करेंगे मशीन कोड में, and after that we will perform the right shift operator on this. देखो, after performing this right shift operator we got this result. Okay, हमें ये result मिल गया। लेकिन अब जो ये code which we are getting it over here is, this code is a machine code, and again you know that for negative number, machine code is not equal to your logical code. So to make what this code is representing, which number this code is representing, what we again perform, two's complement. तो अगर हम इसमें फिर से two's complement perform करेंगे, so what we will get the output like that. Okay, so that is why we are getting the output as what your -15. Got the concept?
Yes sir.
Okay, like this.
Excuse me, sir.
Yes,
So
So when
actually,
we are
yes.
shifting it to the right, there will be a blank bit in the most significant bit.
Yeah. It's same thing I'm telling you. This is the, I got your question. So he is asking that key, for example, whenever we are going to shift the bit, okay, so we have two part, data part, or you can call it as your value part, and your sign part. So again, this is a very good question. So if we are going to perform the right shift operation, so you know that because we are shifting one position towards this direction, okay, so what we will get one blank space over there. ऑलवेज रिमेंबर, बिकॉज हमारे डेटा वैल्यू में एक हमें क्या मिलेगा, एक प्लेस ऐसा मिलेगा जो ब्लैंक होगा। सो इन दैट प्लेस हम क्या फिल करें, 0 फिल करें या 1 फिल करें? सो इन द केस ऑफ योर साइंड राइट शिफ्ट ऑपरेटर, ऑलवेज रिमेंबर, इन द केस ऑफ योर साइंड राइट शिफ्ट ऑपरेटर, ऑलवेज try to enter 1 over there. Okay, always enter 1. So that is why I have entered 1 over there. Got your answer?
Yes, sir.
Okay.
And so we don't have to shift the MSB.
Yeah, in the MSB. So whatever the number we are able, so we are not going to perform this operation. So MSB will remain same. Okay. So we are not basically shifting our this. So only in the case of your this complement operator, always remember, only in the case of your complement operator, your negative number will participate. Okay. Means sorry, your signed bit will participate here. No need to perform this operation on signed bit. Only this part, only the value part where we are going to perform this your right shift operation. Got it? So that is why we will get only one place here, one blank space we will get it over here. So which value we should print over there? So we will generally put 1 over there. Okay, so whatever the value we have in our signed bit, we generally put it over there. So for negative number we always get 1, so that is why we will get always 1 over there. Now similarly we have unsigned, so this is a unsigned right shift operator, signed right shift operator, we have unsigned right shift operator. So the difference is again the same. While here in this scenario what we are doing it, we are performing the same operation like that. Okay, but in the case of your unsigned right shift operator, what we are going to do, we are going to means enter 0 bit here. Okay, means we are going to make our negative number into positive, you can call it as. Okay, we are going to convert our signed bit into your unsigned. So for positive numbers, whenever you are getting positive number, if I'm going to perform the right shift operator or your unsigned right shift operator. Okay, unsigned right shift operator are basically represented like these three arrows. Okay, and right shift operator are signed right shift operator represented by two arrows. So in both the scenarios, so for positive number you will get the same result, you will get the same output. Why? Because your MSB bit in both the case are what, your 00. So that is why you will get the same output. But in the case of negative number, for signed right shift operator as well as for your unsigned right shift operator, what will happen? You will get different output. How you will get the different output, we will see. So here in this case, so you already know that suppose this is my MSB. Okay, this is my MSB bit and this is what my value part or data part. Okay, so if I'm going to perform the for negative numbers, if I'm going to perform this unsigned right shift operator, then what will happen? I'm going to perform, so sorry, here I have made a mistake. Here you will get 0 in your blank space. In the blank space over there we are inserting which value? Your 1 value over there. But here in this case we are going to insert your which value? Here you are going to fill with your 0 value, and this MSB part will also be your 0 part. Okay, so this is the answer you will get it whenever you are going to perform your unsigned right shift operator on your negative number. Okay, for positive numbers always remember both will give you the same result, but for negative number they will give you the different numbers. So different output. So let's take the same example. So in this example, what we are performing unsigned right shift operator. So earlier case also we have just performed this is representing or representation of signed operator. Okay, signed right shift operator, and this is the representation of unsigned right shift operator. So if you are going to execute the code, so you already know, first of all, for negative number we perform the logical binary code, then we perform 2's complement. You already have an idea about. Then what we are going to do, we are going to convert it into your machine. It means we have to perform this operation. Okay, so whenever we are going to perform this operation, so what I told you that your MSB bit, you have to make your MSB bit as your 0, and whatever the bit you are filling it over there, make it 02. Okay, so I have made this mistake. So here you will get what, your 02. Okay, so this is the number you will get it over there. So once you are going to convert this number, so this number we are getting it. Now this is a question for you, what this value is. So means the question is, should we again perform 2's complement for this number? Yes, anyone?
No, sir.
Yeah. So now we are not going to perform 2's complement. Why we are not performing 2's complement here? Because here we are getting positive number, and for machine code as well as your logical code, both are same. So that is why whenever we are going to perform, okay, whenever we are going to perform unsigned right shift operator on your -30, so this output you will get. You can execute in your machine too after this lecture. So you will see that for positive number, okay, for positive number, just perform, just check it out in your system too, that for positive number you will get, even you are performing signed operator or unsigned operator, you will get the same result. You will get the same result. But for negative numbers, you will not get the same result. So the reason behind that is because we are basically flipping the bit. We are making this your MSB bit into your 0. So, and once we are basically making our MSB to 0, now this machine code and this will become a positive number. And if it is a positive number, then your machine code as well as your logical code both are same. So if both are same, so now just convert this number. So if we are going to convert this number, so this is the output we will get it. Okay, so this is very important. Like, what is the difference between signed and unsigned right shift operator? For positive number, if somebody is going to ask you, so you will say there will be no change. Okay, you will get the same output. But for negative number, definitely you will get a very different, means the difference you can see over there you are getting minus of 15. This is the output you are getting it. But here you are getting positive of your this 2147, this number you are getting. Okay. So this is the difference between your signed and unsigned operator. So both the operation we have performed, so you know that we have performed, first we have converted into logical, then we have performed one's complement, then we have performed two's complement, then we have performed that particular operation. Okay, then we have performed that particular operation, and in our signed bit, our MSB bit, we are getting it as positive +1. It means it is a negative number. Here we are getting a positive number. So if we are getting a negative number, so what this number is, if we want, then we have to again perform 2's complement. So that is why we are getting this number. And here in this case, we are getting a positive number. So no need to again compute it. So that this is the output we are getting. Okay. So this is all about our positive as well as negative
Sure.
numbers. So yes.
So what is the use of this operator, signed and unsigned?
Okay, see, these signed and unsigned. So see, there are different scenarios too. But you already know that sometimes we used these operators whenever, like in your lab also, you have one question where you have to perform multiplication, okay, or division. So what I want to tell you is that suppose you have 0 1 0 0. Okay, this is a representation of your 4. If I am going to perform the right shift operator by 1, so what will happen? You will get 0 0 1 0 over there. Okay, so the output which you will get over there after performing this is what your 2. So it means whenever you are performing right shift operator, so actually you are in bitwise level, you are performing division operation. Okay, division operation. So similar set of operations, sometimes you got scenarios. Okay, actually it depends upon the scenarios. Right now I'm not in the place to tell you about the exact scenario, but yeah, in future I will tell you, like in the next lecture I will find it out, like where we are basically using this unsigned. But sometimes like whenever, like I have an idea about like when we use signed this right shift operator, but I have no idea like where we can use this unsigned right shift operator, because means the application. Okay, application I don't know, but I will search it out. Okay, and I will let you know that what are the basic application of unsigned. For signed, yeah, you will perform like you are going to use it for your division for positive number. For negative numbers I will find it out. Okay, what are the application? Got it? So I
Okay,
will
sir.
let you know that where we are basically using. Yeah, I can tell you about the scenarios also. Like in some scenarios you can use it, but I just want I just want that I should tell you about the application where we are basically using this signed and as well as unsigned bit. So you know that why we are performing right shift operator, left shift operator, because you can perform division, multiplication, and sometimes you have a scenario that I think in your lab there is a question where you have to find out the first up bit. I think this is a question you have like that. Okay, so these such kind of questions you generally solve. There are different ways you can solve this question, out of which one method through which you can solve is using signed bit also. So if I'm going to ask you about that, you have a number. Suppose this is a 1842. This is whatever the number. Suppose we are getting 64 over there. Okay. So if I'm going to ask you about that, in which bit place this it is having a high bit. Okay. That, so how you are going to find it out? So there are different ways, like using masking you can find out. Still you can use some logic, and based on that you can perform shift operator till when you are getting your 1 bit. Okay, and till that moment of time just count plus plus like that. So you will find out, okay, this 0 here you will get 1, you will get 2, you will get 3, you will get 4, you will get 5. Okay, in the 5th place I am having high bit. So here you are performing what your your right shift operator. But for unsigned this for negative numbers, I will tell you about the application. Okay, like that. So this is the entire thing which we have covered in our these lectures. Okay, related. So we have covered all the topics related to your data types, variables, variable name, operators, precedence, and the examples of operators. Just go through it after this lecture. Just try it out in your system. Just try to solve at least 2 to 3 questions by your own. And if you are facing any difficulty, just let me know. And from the next lecture, we are going to start a new topic. Okay? Any question?
No, sir.
Okay. And but please try to solve at least 1 to 2 questions based on these questions. Otherwise, you will forget this concept. Okay. So this concept is very important. So that is why I'm saying that